All right, let's dive right in. Have you ever wondered how we get from a simple what if to a major breakthrough? Well, today, we're going to pull back the curtain on the whole world of research. We're going to walk through the step-by-step journey that turns simple curiosity into solid knowledge.
It all boils down to this one huge question. How do we really know something is true? Really know it, beyond just a gut feeling or what someone told you. This isn't just for academics and ivory towers. It's a real-world quest for answers we can actually trust.
And any good quest needs a map, right? So our first stop is to understand the framework that guides every single credible study out there. We're talking about research methodology. Think of it as the compass that keeps a researcher heading the right direction and not just wandering around in the dark.
So what is this thing exactly? Well, research methodology is the logic behind the whole operation. It's not just about what you do, it's about why you're doing it, how you're thinking about the problem, and why you chose this specific path and not a dozen others. It's the master plan for the entire project.
Now, to really get this, we've got to understand the tools of the trade. And here's where things can get a little fuzzy. People throw around words like methodology, methods, and techniques almost like they're the same thing, but they're not. There's actually a really clear hierarchy here, so let's break it down. Let's make this super simple. Think about building a house. Your methodology is the architect's blueprint. It's the overall why, the grand design, and logic. The methods are the big phases of construction, the what, like laying the foundation, then framing the walls. And the techniques, that's the how. Those are your actual tools, your hammers, your saws, your drills, the specific things you use to get the job done. See? Why, what, and how.
Okay, so now that we know what's in our toolkit, we can actually start walking the path. This is the core journey, a sequence of steps that pretty much every researcher follows to make sure the process is logical, thorough, and makes sense from start to finish.
This flowchart lays it out perfectly. First, you have to define the problem. You got to know what you're trying to figure out, right? Then, you do your homework. You see what other smart people have already said by reviewing the literature. Based on all that, you make an educated guess, a testable idea. That's your hypothesis. Next, you design the whole study, figure out your game plan. Then comes the fun part. You actually go out and collect the data. And finally, you analyze it all to see what you've found.
But hold on, the journey doesn't just end with a spreadsheet full of numbers. The final and arguably most important step is to interpret what it all means and then report your findings. This is where raw data gets turned into actual knowledge that can be shared, so the next person can build on what you've learned. Okay, so within that whole process we just walked through, researchers come to a huge fork in the road. They have to make two massive choices. Where are they going to look for their answers, and who or what exactly are they going to study? These decisions pretty much define the entire project.
You've basically got three main playgrounds for research. You can do library research, which is all about digging through historical records and documents. Or you can do field research, where you go out into the real world and observe people or survey them in their natural habitat. And then there's laboratory research, where you create a controlled environment to study behavior up close. The question you're asking always dictates which arena is best.
But here's the thing. You can't interview every single person in a country, right? Or test every product that comes off an assembly line. That leads to one of the biggest challenges in all of research: sampling. How in the world do you pick a small group that can accurately represent the whole shebang?
Well, there are two main ways to tackle this. On one hand, you have deliberate sampling. This is where the researcher uses their expert judgment to handpick specific people or cases for a reason. On the other hand, you have simple random sampling. This is like a lottery. Every single person in the group has an equal random chance of getting picked. It's all up to pure probability.
And trust me, it gets way more sophisticated. For example, a researcher might use stratified sampling. That's where you divide the population into important subgroups, say by age, to make sure you get a fair representation from each one. Or they could use systematic sampling, where they just pick every 10th person off a list. Each technique is just a different tool to do the same critical job: get a small sample that truly reflects the bigger picture.
So after all of this planning and designing and sampling, how do we even know if the result is trustworthy? What's the difference between good research and, well, jump? This quote from James Harold Fox absolutely nails it. Good research isn't a magic trick performed behind a closed curtain. It's a transparent process. It's like showing your work in math class. You have to describe your steps so clearly that anyone else can come along, repeat them, and see if they get the same result. That idea, replicability, is the absolute bedrock of scientific trust. So,
Building on that, all genuinely good research has these 4 essential qualities. It has to be systematic, it follows a clear, structured path. It has to be logical and guided by sound reasoning. It must be empirical, which means it's based on real-world data you can observe, not just theory. And, as we just saw, it absolutely has to be replicable.
Now, I know what you might be thinking. This all sounds like a very clean, straightforward recipe. But let me tell you, in the real world, this journey is almost always filled with bumps and roadblocks.
Researchers face a ton of real-world hurdles. There might be a lack of good scientific training or a total disconnect between universities doing the research and the industries that could actually use it. Businesses can be super reluctant to share their data. Plus, you might have overlapping studies, terrible library access. The list just goes on and on. The key takeaway here is that conducting good, solid research is anything but easy.
So, there you have it. You've got the map, you understand the journey from a question all the way to a conclusion, you know the tools they use, and you know the standards that separate good research from bad. This process, this whole thing, is how we build our understanding of the world. And that leaves me with just one final question for you. Now that you know how it all works, what do you think is the next big question we need to answer?